See another question. A concave lens of focal length 15 centimeter forms an image 10 centimeter from the lens. How far is the object placed from the lens? Here you have to calculate object distance. Can you do this? Try. Otherwise, now I am going to take this exam again this solution complete. What will you take first? Focal length. This is a concave lens. You will be writing focal length minus 15 centimeter. Image V is equal to minus 10 centimeter, because image is formed left to the optical center, that is opposite to the direction of incident rays. So, we can calculate U from here. You know this formula 1 upon F equal to 1 upon V minus 1 upon U. This is 1 upon minus 15 is equal to 1 upon minus 10 minus 1 upon U. So, we can write 1 upon U is equal to 1 upon minus 10 plus 1 upon 15. LCM is 30. So, minus 3 plus 2, that will be minus 1 upon 30. So, you can write U is equal to minus 30 centimeter. It means object should be placed at a distance of 30 centimeter in front of the lens. So, now you can do these type of numericals. These are very simple numericals. If you try them easily, you can solve. Now, we will study power of lens. So, power of lens, as we have done converging and diverging lens. So, we can take here power of lens. So, see, power of lens, the degree of divergence or convergence by a lens is known as power of a lens, but it is defined as the reciprocal of focal length in meters. So, power of lens we represent by capital P. So, we can write P is equal to 1 upon F, but focal length is in meters. So, it is very simple to define, but actually it is the degree of divergence or convergence by a lens. So, unit of power of lens is written as unit is diopter, which is represented by D. It can be plus minus D. As we know, focal length for convex lens is positive. So, power will be positive. So, plus D for convex lens. If you are taking concave lens, focal length is negative. So, power will be negative. So, now I am giving you a simple question related to this. If you have got, just we can take an example here. If you have focal length is equal to 10 centimeter, find its power. So, how will you calculate power? Power is equal to 1 upon F, but focal length is in meters, centimeters. So, we have to convert into meters. So, we can write 1 upon 10 divided by 100, that we can write P is equal to 100 by 10. It is in diopter, or also you can write m raised to power 1 inverse of meter. So, this is here 10. So, power is equal to plus 10 diopter. We can do its other way this question, like if you take power of any lens. Suppose you are given power of a lens. So, if you are given power of lens, suppose minus 5 diopter, find focal length and guess nature of lens. So, nature we can easily guess by seeing negative sign, because if negative sign is here, that is a concave lens. Now, we can write power is equal to 1 upon F. So, we can write minus 5 is equal to 1 upon F. So, F is equal to 1 upon minus 5 meter, because focal length was in meters. but if you have to convert into centimeters, so 1 upon minus 5 into 100 is equal to minus 20 centimeter. So, power of lens you can calculate by, if the focal length is given, and if power is given you can calculate focal length. You know, power can be added algebraically, like total power if you are going to add, you can write P is equal to P1 plus P2 plus like this, whatever the number of lenses you can add. And this is very important concept for making making instruments like, you know, microscopes, you can say telescope, all that things we can make by using this concept, because it reduces spherical aberration or the defect of the lenses can be minimized by combining the power.